Hello everyone. In this session we can consider some examples. It is to find the ground state configuration of magnetic ions applying Hund's rules. So the first step was to maximize S. That is, electrons are arranged in subshells according to Pauli's exclusion principle to get a maximum value of spin angular momentum S. So in doing so, the Coulomb repulsion between the electrons are reduced and this minimizes the energy. Second step was to maximize L, and here also the Coulomb repulsion between electrons are reduced and minimizes the energy. And the third step was to find J according to the condition J is equal to L plus S if the subshells are more than half filled, and J is equal to L minus S if the subshells are less than half filled, and J is equal to S if the subshells are just half filled. So by selecting these type values of J, we will be reducing the spin orbit interaction or spin orbit coupling. That is, LS coupling and JJ coupling. So spin orbit interaction is also reduced by selecting these J values, and this also reduces the energy. So these were the Hund's rules, three rules. Rules were according to their first rule was to maximize S, second rule was to maximize L, and third rule was to find J according to these three conditions. Now let us consider an example. Consider promethium 3 plus ions where its subshell is 4f4. That is, its incomplete subshell or unpaired electron is in F level, and there are 4 unpaired electrons. So since this is F subshell, so it will be having states. This F subshell can accommodate 14 electrons. It will be having 7 subshells and it can accommodate 14 electrons. And since this is F subshell, for F the value of L is 3. So the ml values will be 3, 2, 3, 2, 1, 0, minus 1, minus 2, minus 3. So there are 4 electrons. So what we have to do? We have to accommodate these 4 electrons in such a way to get maximum value of spin. For that we have to arrange the 4 electrons in each 1 electron in one subshell, and that too in the up state, to get a maximum value of S. So what will be the resultant value of S? So only if we arrange electrons in this manner we get a maximum value of S, and this is in accordance with Pauli's exclusion principle too. So what is the value of S? There are 4 spin states and each is having up spin. So its value is plus half. So 4 into half, that will be 2. So we get S as 2. S is equal to 2. Next we have to find L. So what is the L value here? We have to add all the ml values here. So adding these ml values, what we get? 3 plus 2 plus 1, that is 6. 6 is the L value. So L is equal to 2. Sorry, S is equal to 2, L is equal to 6. So what is J? J is equal to, so look at these subshells. This is complete, this is less than half filled because it has only 4 electrons. So it is less than 7. So it satisfies the condition less than half filled. So what is J? J is equal to modulus of L minus S. That is 6 minus 2 is equal to 4. So how to represent the ground state? It is 2s plus 1 Lj. This is the term symbol for ground state configuration. And what is 2s plus 1? 2s plus 1 is the multiplicity, and here s we got as 2. So 2s plus 1 will be 5. And what is L? L we got as 6. L is equal to 6 corresponds to which state? S, P, D, F, G, H, I. So this corresponds to the symbol I. And what is J? What is J? J is equal to 4. So how we can represent this? Instead of 2s plus 1, it is 5I4. So promethium 3 plus ion with its subshell 4f4, its ground state configuration is 5I4. 5I4. Next we can consider another important ion, gadolinium 3 plus, having 4f7 electron shell configuration. So there are 7 electrons, and since this is f subshell, again we have 7 subshells. Each subshell can accommodate 2 electrons, so a total of 14 electrons can be accommodated here. So these 7 electrons are arranged in such a way to maximize S. That is 7 electrons, it can be accommodated in each subshell, and each electron will be having spin up. So this state is just half filled. If there is one more electron, it will be accommodated in this state as down spin. So what will be the value of S? There are 7 electrons. 7 into each electron is having a plus half, that is 7 into half, that is equal to 7 by 2 is S. And what is L value? That is the summation over ml. So adding all these values, that is 3 plus 2 plus 1 plus 0 plus minus 1 plus minus 2 plus minus 3, it gets cancelled. That is L is equal to 0. So we already stated this, L is equal to 0 for just half filled state. So what will be 2s plus 1 2s plus 1 Lj. 2s plus 1 will be 2 into 2s plus 1, that is 2 into S is 7 by 2 plus 1, that is 8. And L is equal to 0. L is equal to 0. And what is J? J is equal to, since it is just half filled and L is equal to 0, J is equal to S, that is J is equal to 7 by 2. So how we can represent this ground state configuration? 2s plus 1, that is 2s plus 1, we got it as 8, and L is equal to 0 means it is S state, and J we got it as 7 by 2. So 8 is 7 by 2 is the ground state configuration of a gadolinium 3 plus ion. Now we can consider another metal, that is transition metal. For transition metal, the unpaired electrons will be in their 3D subshell. So here it is D subshell, so its L value is 2 and ml values are 2, 1, 0, minus 1, minus 2. There are ml values are 2l plus 1 values, that is here it is 5 ml values are there. So we are considering a 3D 3 plus ions. So how will it look like? There are 5 subshells. 1, 2, 3, 4, 5. We are considering 3D 3 plus ion, and here ml values are 2, 1, 0, minus 1, minus 2. There are 3 electrons. So the 3 electrons are arranged in such a way to get maximum value of S. So this is the arrangement in accordance with Pauli's exclusion principle. So what will be the value of S? There are 3 electrons with up spin, that is 3 by 2. And what is the L value here? Adding all these ml values, that is 2 plus 1 plus 0, that is 3. So what is J value? J is equal to L plus S or L minus S. Since it is less than half fill, it is L minus S. J is equal to L minus S, and L is 3 and S is 3 by 2, that is 3 minus 3 by 2, it is again 3 by 2. So how we can represent this? 2s plus 1. 2s plus 1 is S is equal to 3 by 2, that is 2 into 3 by 2 plus 1. 4. 2s plus 1 is 4. So we can represent this as 2s plus 1 Lj, that is 2s plus 1. 4. What is the value of L? L is equal to 3. L is equal to 3 corresponds to SPDF. L is equal to 3 corresponds to F. And what is the J value? J is equal to 3 by 2. So these are some of the examples to find the ground state configuration of some magnetic ions, both rare earth and 3D transition metals. Hope all of you understood how to write the ground state configuration. Thank you all.